Okay, so this video is to help you complete page 24, and what we're going to do is we're going to prove these things called the double angle formulas. If you look at your formula sheet, there's a title that says double angle formulas, and these are formulas we use when we have sine of 2 theta, cosine of 2 theta, or tangent of 2 theta. And I just want to prove you where the formulas came from and not that they just appeared. So we're going to start at the top of page 24. And so it says that you have sine of 2 theta. And we're just going to rewrite that 2 theta as sine of theta plus theta. Now by doing this, I have written a sine of a alpha plus a beta. And that's going to let me use my sum and difference formulas. So if I were to expand this sine of theta plus theta out, it would equal sine of theta cosine of theta plus cosine of theta sine of theta. And all I did was I used the formula. This was an alpha in the formula, this was a beta, and this was an alpha in the formula, and this was a beta. And now if you look what we have, one says cosine sine, and the other one says sine cosine. Well, those are the same thing. 2 times 3 is the same thing as 3 times 2, and thus we have 2 sine theta cosine theta. And that is also equal to sine of 2 theta. So this is your formula right here. This is your formula, your double angle formula for sine of 2 theta. So you want to make sure you write that down on page 24. And then on the left side and on the right side, you want to write that down in your little formula box. Now we're going to do the exact same thing again, only we're going to use cosine. So same exact concept though. Cosine of 2 theta is equal to cosine of theta plus theta, where this is your alpha and this is your beta. And that, when you use the sum and difference formula, is going to become cosine of theta minus sine of theta sine of theta. And that will equal cosine squared theta minus sine squared theta. And that's going to equal cosine of 2 theta. If you notice on your formula sheet for cosine, there are multiple versions of this formula, and that's because what we then use is we can use the Pythagorean identities for either sine squared or cosine squared and replace them. So this formula right here, double angle formula for cosine, comes in 3 versions. This is the first version. If I take my first version and I replace, hang on, let me fix that. It's not what I meant to write. And I'm going to replace this right here. Cosine squared is equal to 1 minus sine squared theta minus the sine squared theta that was already in my equation. This still equals cosine of 2 theta. And so now I have 1 minus sine squared, so this is 1 minus 2 sine squared theta. And this also equals cosine of 2 theta. And then I'm going to go back to the cosine squared theta minus sine squared theta equals cosine of 2 theta. And instead of replacing the cosine, I'm going to replace the sine squared with a 1 minus cosine squared theta. And then I just want to be careful that there's a negative out front. This negative right here, I have to hold on to it right there. And then I still have my cosine squared theta out front. So when you distribute your negative and simplify this, you're going to get that you have So now you have 2 cosine squared theta minus 1, and this is going to equal cosine of 2 theta. So make sure you have the proof for all 3 versions on the left side of page 24. And then on the right side of 24, you'll notice that next to cosine of 2 theta, there's a bracket. That's so that you can write all 3 versions because they're all equivalent. And we just use whichever version's more useful in the situation that we have. For example, if we know what cosine is, it's more useful to use this version right here. If we know what sine is, it's more useful to use the version that has the sine in it. And the sine squared minus cosine squared becomes useful if we know tangent, and then we can find sines or cosines. And finally, we're going to prove the tangent one, and same thought as before. We're going to let tangent of 2 theta equal tangent of theta plus theta. And then we're going to use our sum and difference formulas. And tangent of theta plus theta, or alpha plus beta, can be expanded using sum and difference. So it's a fraction, and you're going to have tangent of theta plus tangent of theta over 1 minus tangent theta, and that becomes on top, there's 2 tangent thetas, and on bottom we have tangent times tangent, which is really tangent squared theta, and that is equivalent to tangent squared. Oh, no, sorry, not tangent squared. I don't know why I keep doing that. Tangent 2 theta, thus being the double angle formula. Again, make sure the work is on the left column and the final formula you have written down on your right column on page 24.